This is GCSE Further Maths. Mechanics, we are looking at connected particles in chapter 4, and these are some of the harder pulley questions. I would suggest that these are beyond the scope of the course, however they're still good practice to see how they work. So two particles, 2 kilograms and 5 kilograms, are connected by a light and extensible string which passes over a smooth pulley. The 2 kilogram lies in a smooth horizontal table and the 5 kilogram body hangs vertically as shown. Calculate the acceleration of the system when released from rest, the tension of the string and the force exerted by the pulley. So drawing on our force, we have our forces kind of pretty much here. We know that it's going to accelerate this way here, so that would be A meters per second squared, and it's going to accelerate this way here. We're going to do F equals ma for each of them. This is going to be our part 1. So for the, first of all, the 5 kilogram force, F equals ma, and what do we have? We have 50, take away t equals 5a. For the 2 kilogram one, there's actually not too much going on. It's nice and straightforward. The only force acting in this one is the T, pulling it this way, and T equals 2A. So if we sub, I guess, 2 into 1, so we're substituting equation 2 into 1. So what am I doing? Anytime I see a T, I'm going to exchange it then for 2A. So 50 take away 2A equals 5A. 50 equals 7a, so a is 7 and a 7th meters per second squared. Sorry, you couldn't see that. So 50 take away 2a is 5a, 50 equals 7a, and a then is 7 and a 7th meters per second squared. The tension in the string is the next part we're asked for. So if we do part 2 then over here, again nice and straightforward. If we just use t equals 2a, so t equals 2a, t equals 2 times 7 and a 7th, so tension then is 14 and 2/7 newtons. The force exerted on the string by the pulley, by the string on the pulley. So what's happening here with this pulley? It's being pulled this way with a T and pulled this way with a T. So effectively our resultant force is going to be going this direction here. How do we actually work that out? We lift this force and put it on the end of this force and we can work it out. It's kind of a combination. We did one earlier on with a regular pulley system, and we also then, this is like putting two things tip to tail. So we are going to take, this is part 3 obviously, take the tension which is going that way, and on the end of it we're going to stick the other tension. So from the start to the end then will be the resultant force there. Because the tensions are equal, then our angle is going to be 45 degrees. You can do T over T and you'll get the same thing either, but our angle then is 45 degrees. That's the way it's acting. In terms of working out an R squared equals T squared plus T squared. That's using Pythagoras. R squared is 14 and 2/7 squared plus 14 and 2/7 squared. R squared, I believe, comes out to be 408 if you put that in your calculator, 1633, and that means our R then is 20.20, and that's the 2 decimal places.